Alright, this video is to review solutions. I'm going to go over some key stuff that you need to know for solutions for Kung Fu Quiz number 9. First thing is solutions we measure. There's three major ways we measure concentration in chemistry. First one is molarity. Molarity is going to be moles over liters. Moles of solute over liters of solution. Should know that already. Molality, if you remember, is moles over kilograms. It's moles of solute over kilograms of solvent. So that's the difference really. And then finally, mole fraction. If you need to find mole fraction, you put the total number of moles on the bottom. So everything you're given, change it to moles, put those on the bottom, and then the part that you want on the top. Mole fraction is used in Raoult's law for calculation of vapor pressure lowering. Okay, so those are three ways that we calculate concentration in chemistry. Remember, we talked about this. The magnitude, the number of particles dictates what the magnitude of the change is going to be when you're talking about freezing point. Remember, freezing point is a depression. So when you're trying to find the highest and the lowest, first thing you check to see if the molalities are all the same. Because normally it's Kf times m times I equals the freezing point depression. If you notice, they're all aqueous. So since all these are aqueous, you know that the Kf doesn't really matter. So what you have to do is you're comparing m times I, the Van Hoff factor. The Van Hoff factor, if you remember, is the number of ions something breaks into. So for example, this only breaks into one unit, it's molecular. HCl is a strong acid, its Van Hoff factor is 2. MCl2 breaks into 3. And Al2SO4 breaks into 5 ions. So then what happens is you multiply the Van Hoff factor times the molality. For this one I get 0.010. 2 times 0.008 is going to be 0.016 for that one. 3 times 0.005 is going to be 0.015. And then finally 5 times 0.003 is going to be 0.015. So the greatest number of particles means the greatest depression and freezing point. So B would have the lowest freezing point because it has the greatest number of particles. A would have the highest freezing point because it would have the least number of particles. Key thing you need to remember is this. As the number of particles or ions increases, there's three things that basically go with it, a direct relationship. Boiling point increases as you increase the number of ions. Osmotic pressure increases as you increase the number of ions, and so does electrical conductivity. The two things that are inverse are freezing point. So the one I just showed you, you had freezing point, and then as you increase the number of ions, freezing point and vapor pressure get lower. If you flip this arrow over, so if I take this arrow and I flip it over, what happens is all these flip over as well. So then basically what you would end up with is you would have a lower boiling point, less number of ions, you would have a lower electrical conductivity, lower osmotic pressure, and then freezing point and vapor pressure would be higher the lower particle size you have, or lower particle amounts you have. If we notice right here, first thing I notice if they're asking me, they want approximate. First thing I notice is the molarities are all the same, and they're all aqueous. So really, they're asking us, what's the Van Hoff factor? The difference between them. The Van Hoff factor for this would be 1. The Van Hoff factor for this would be 3. Since this is a weak acid, we would say the Van Hoff factor is slightly greater than 1 because it's a weak acid, so that's going to break up probably less than 5%. So really, the lowest freezing point would be B, then it would be C, and then finally A. And that's all based on the Van Hoff factor, and applying the number of particles dictates what's going to happen. If you look right here, first thing I notice, aqueous, which means the Kf is going to be the same because it's water. Notice the molalities are all the same, so I cancel those. So then it comes down to lowest freezing point is going to have the greatest number of particles because I go back to this grid right here. So lowest freezing point is directly connected to the smallest or greatest number of ions. So if I go back through here, Van Hoff factor here is 1. Pure water, pure substance has no particles in it. It's going to be 0, 2, and 3, and 1. So the correct answer for this choice would be, or this question, the correct choice would be D. That would have the lowest freezing point. You got to understand the relationship before you even start. One of the things that happens more on the free response than anything else is you are required to calculate out the freezing point by molar mass method. So you find molar mass by freezing point. The way it works is simple. You just take the Kf negative KFP because we always make it negative, times grams of solute on top of the fraction, kilograms of solvent on the bottom, and the temperature change of the delta T on the bottom. Plug those all in. It's an easy way to find molar mass of a solute using freezing point depression. If you look right here, here's a sample problem we've looked at before. I have 1 gram of sorbitol and 100 grams of water. Well, the gram of solute, the 1 gram goes right there. That's where it is in the equation. The KF for water, you should know that or be able to look it up in a book. They would give it to you, is negative 1.86. The change in temperature of water, water normally freezes at 0. It's depressed, it's negative 0.102. Goes down there, so that's my delta T. Finally, the amount of solvent I have is I have 100 grams, which means I have 0.100 kilograms. Okay, plug that all in, and I get a molar mass of 182 grams slash moles. We did a free response problem. You guys did one for homework. Have to be able to do that on multiple choice, but really free response more than anything else. Other couple things that are covered. Remember when we do a KSP expression, the solids are listed on the left. We break up into the ions. The subscripts become coefficients. You have to pay attention to subscripts when you're calculating molarities and stuff like that. So if you dissolve like CAF in solution, you're going to have double the amount of F minus as Ca. So you have to pay attention to that when they ask you molarities, ion concentrations. Make sure you're paying attention to the subscripts. If you have to write a KSP equation, remember solids are never included. So that would be a KSP, how you would write out a KSP expression. Common ion problems, they will ask you, hey, which one will affect or least soluble, which one will be most soluble. Really, they focus on least soluble. When they do that, they ask you that, you have to look on the right-hand side at the ions. So you'll be adding solutions that contain a common ion. Well, there's no Cl in this, and there's no Mg. So really what we're doing in this problem is we're trying to see which one is going to give you the greatest ion concentration. If you plug in 0.5 Ca from the first one, that's going to go here. This one, notice how it's F2. What do I do to the molality? I'm going to double it to 0.1 molality. So I'm adding 0.1 molality there. Remember, it's a Le Chat problem. The more you add, the more it's going to shift. So it's going to be least soluble, but since I'm adding more here, I'm adding more F minus just because of the molality based on taking the subscript times the molality. It's going to cause a greater shift this way. So CAF would be less soluble in MgF2 than it is in CaCl2. So when you look at it, first look at the right-hand side of the equation. See which ions are common to the right-hand equation and look for which one has the greatest molality first. And then if it's tied, it's not tied in this case simply because the F has 2 of them, so you're going to double that. If it's tied, then you go for the one with the larger coefficient, would cause a greater shift. Last thing, comes in solutions a lot, is there in the practice quiz. Like dissolves like. It's just something that we use in chemistry. Polar molecules dissolve in polar substances. So like if a substance is polar, it will dissolve really well in a polar solvent. So if you have a nonpolar substance have to be dissolved in nonpolar substances. So for example, if you take C4H10, right? That's going to be nonpolar. If you take CCl4, that would allow it to be very soluble in that, because CCl carbon tetrachloride is a nonpolar substance. So you could dissolve C4H10 in that solution simply because it is a nonpolar substance that will dissolve in a nonpolar substance. That's how we determine solubility, or how well something is soluble in a given substance. All right, that should be good enough for you guys to review. That should help you go through the Kung Fu quiz. Make sure you load your answers in a Quizstar. Have a good evening.